Hello friends, welcome back to my YouTube channel. So in today's video we'll see the what is normal thrust and radial shear. So we'll see. So I have taken a arch. So this is the horizontal thrust H, and here also H, and reactions are R and RB are the reaction. This is the rise, from here to here is the rise, and the span from here to here is the span. So in this arch, so I have taken a point here. I have considered a point here, and at that point I have drawn tangent to this surface. So now the forces which is acting along this tangent, it may be anywhere, here or here or here, that forces we'll call it as the normal thrust. The forces which is acting along this tangent, we'll call it as the normal thrust, and the forces which is perpendicular to this normal thrust, we'll call it as the radial shear. So this is the perpendicular. Along this perpendicular, the forces which is acting perpendicular to the normal thrust, we'll call it as the radial shear. So now if I cut the section here, now I'll draw the pre-body diagram of this section. So have redrawn this section here. So here, so one reaction and one horizontal force is there. To balance this reaction, here one force will come, we'll call it as the HD, and to balance this reaction, here one force will come, we'll call it as the VD. So now this is the tangent line, and our HD as the two component. One is here, it is called as the HD cos theta, and perpendicular to this one more component will be there, we'll call it as the HD sin theta. So at 90 degree it will come. So in the similar way, VD has the two component. One is the VD cos theta, and perpendicular to this means it comes here at 90 degree, VD sin theta. So now both as the two components, the HD components will be HD cos theta and HD sin theta, and VD components are VD cos theta as well as VD sin theta. So at beginning, so here what I said, the forces which is acting along this tangent, we will call it as the normal thrust, and the forces which is perpendicular to the normal thrust, we will call it as the radial shear. So as per our definition, how many forces are acting along this tangent? There are two forces acting. If you look at the formula of the normal thrust, if you remember in the beginning what I have said, the how many forces are coming along this, how many forces are along this tangent, we will call it as the normal thrust. So now how many forces? One is HD cos theta, another is VD sin theta. So our normal thrust formula will be become, both are same direction, so that I will write here short NT. So HD cos theta plus VD sin theta, this is the formula for normal thrust. So now we'll see radial. So now radial shear means the forces, how many forces are acting along this? One is VD cos theta, another is HD sin theta, both are in opposite direction. So this is upward, means HD, we need to take the positive sign. So HD sin theta minus, it is downward, VD cos theta. So radial shear formula is formula of the radial shear is HD sin theta minus VD cos theta. So I taken here minus means, so this is downward, so VD cos theta is moving downside, And here HD sin theta I have taken positive because HD sin theta is moving upward. So the formula of the normal thrust and radial shear. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.